So we got problem number 2. The function f of x equals x cubed is shown. Graph and label the function g of x equals x to the 7th power on the same coordinate plane. So we drew the function graph thing, and yeah, like I said, function f of x equals x cubed. So this is our graph, and it's going to be wider, and it's basically kind of going to be the same because they're both odd numbers, except for function g of x equals 7, it's going to be more steeper. So when we draw the graph, it's basically going to be the same. So just going to go like,
our problem is to turn function k of x equals
like
x
that, and this is function g of x.
Say whether the graph is even, odd, or neither.
The answer would be neither, because it's not symmetric to the origin. Like here it's x1 and it's just a straight line, and obviously it's not straight, and x squared goes like a u, and this one's neither a u, so it would be neither.
Okay, so first we have to write the equation out first. And from here what we have to do is we have to sub negative x for every x, so your equation would look like this. So that's going to be the equation after you sub.
So the next step would be to solve it. So you would get negative 3x cubed plus 2x squared plus 5, and this equation is not even.
Alright, so this shows that this is not even because this doesn't match. Okay, let's try do the distribution. Oh, no, not left-handed. Negative 3x cubed plus 2x squared plus 5. If I distribute them all, I would get 3x squared negative 2x squared minus 5. So this is not this is not odd because it still doesn't match. So it's neither, because none of those equations match to this.
So this is question number 6. It's f of x equals x to the 5th power, and what we're going to do is transform it to g of x equals 4f x minus 6 minus 2. And the 4, I'll explain like what the 4 in front of the f is, and it's for the to vertically stretch the graph by the factor of 4.
Then we have parentheses. We have x minus 6. Now, in math, when you see parentheses, usually it's the opposite. So here we have negative 6. When you think of negative, you usually think of going to the left if you're thinking like a graph, like a coordinate plane. But since it's parentheses, you're actually going to be moving to the right. So we have negative 6, you're going to actually moving 6 units to the right. And we have negative 2, and that affects the y-axis. Now, it's not in parentheses, so it's just going to be what you see. So if you were to see plus 2, you would go 2 units up. But it's minus 2, so you're going to move 2 units down.
Alright, so our question was question number 7, and for our problem we had to graph the basic cubic function k of x equals x to the 3rd power as p of x equals k to the power of x plus 3. So we use this equation, this function, and we see that the 3 in p of x equals k of x plus 3 axis C. So we're gonna subtract 3 to the reference points, and we're gonna get the corresponding points, which are -3, 0, -2, 1, -1, 8. And then Brandon's gonna grab that.
This is Angie, Lissa, and Angela, and we're going to do question 8, which is list the number of extremas for each type of polynomial. 8a is a 5th degree polynomial, and using the formula extrema equals degree minus 1, we subtract 5 minus 1, which means the extrema is 4. And 8b is a 6th degree polynomial, and using the formula again, we subtract 1 from 6, and the extrema equals 5.
Okay, so we got 11a, which says sketch a set of functions whose product builds a function with the given characteristics. In that case is degree 3 and 3 real distinct zeros. So this right here is a quadratic function, which is a degree of 2. And over here is a linear, which is a degree of 1. And you add those 2 degrees, which is 3 degrees with 3 real zeros. You can stop now.
Ready? Hello classmates. Today we're gonna explain the answer for the problem number 13a. The question was which polynomial which polynomial function has n of x or k of x has a greater relative maximum. At the beginning we appreciated a graph that had 2, 4, 2, 4, 2, 4, 2, 4, right? And this relative maximum, I'm gonna explain a little bit better for you guys. Here will be the relative maximum of this one. I said the relative because the graph is going have the arrows up. It can create many more relative maximums. But then right here, this is a relative maximum because it's above of the x-axis. This one's below the x-axis. So this makes that this problem was the answer for question 13a. We love math. Take care.
Math.
Say it again.